Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5, Class B. We would like to present our project of wastewater treatment plant. We would like to explain about fluidized bed biological reactor. For the first, let us introduce ourselves. My name is Masteryna Maghfirahdina. Number student number student is 56. And next,
My name is Muhammad Purnama. My study number is 55.
My name is Bagus Tri Wibowo and my study number is 57.
And my name is George Marchellino Panese and my study number is 58.
fluidized bed reactor is a type of biological reactor that can be used to react materials in many ways. This type of reactor uses a fluid which is flowed through a solid catalyst at a sufficient speed so that the catalyst will be rejected in such a way, and finally the catalyst can be analogized as a fluid too. The fluidized bed biological reactor can be used for mixing and separation between phases using the help of microorganisms. Fluidized bed reactor is used for aerobic treatment of low BOD concentration wastewaters, toxic organic biodegradation, biodegradation of COD, anaerobic treatment, denitrification, upflow sludge blanket reactors, air stripping by McGraw-Hill. And next,
Type of detail tool specification. Discard, velocity, and sample design. Next. This is a design about fluidized bed. The most common from the fluidized bed biofilm reactor is the two-phase system, which is shown systematically in figure 8.8a, and effluent recycle line serves two crucial purposes. First, it controls the upward flow velocity to maintain the proper degree of bed fluidization independently of the influent flow rates, which might be variable or too low to allow fluidization. Second, oxygen is transferred to the system via an oxygenator system built into the recycle line. These oxygenator systems often are patented device by McGraw-Hill. Next. An alternative from fluidized bed biofilm treatment is the three-phase system, which is illustrated systematically in figure above. While three-phase system usually maintain effluent recycle to control expansion, oxygen is supplied by direct air sparking into fluidized bed. Air sparking are at least three aspects of fluidized bed operation. First, the presence of the gas phase reduce the liquid hold up, which decrease the liquid detention time and increase the water interstitial velocity. Second, the effect of the gas phase modify how the solid carrier are expanded in response to the upward water flow. Although the response is complicated, but aeration generally causes a decrease in the FBA for the same. Next.
and the next is study case about types of wastewater characteristic and removal efficiency. Based on the journal that we use, biodegradation of organic content in wastewater in fluidized bed bioreactor using low-density biosupport at 2014. In this study, we observed COD levels in domestic wastewater. A new biocarrier made up of low-density polypropylene of surface area 524 millimeter persegi per particle and of density 870 kilogram per meter cubic was used in the treatment of wastewater using fluidized bed reactor. And the below is the specification for the machine. And this is the design according to journal. And this is the diagram, the result diagram. First diagram is effect of bed height on percentage of COD reduction. From the data above, the best percent COD reduction is at a bed height of 0.8 meter. Hence, all the experiments were performed at a bed height of 0.8 meter. And the next is the diagram of percentage of COD reduction in concentration 910 milligram per liter, concentration 1820 milligram per liter, 2840 milligram per liter, 3940 milligram per liter, and the last is the effect of initial on percentage of COD reduction. The highest is on concentration 910 milligram per liter. And the conclusion, a maximum COD reduction of 96.7% was achieved with the operating conditions of 0.8 meter bed height and 0.003018 meter per second superficial gas velocity for an initial concentration of 910 milligram per liter. Number 2, percentage of COD reduction increases as the superficial gas velocity and HRT increases but decreases as the initial concentration increase for a fixed bed height of 0.8 meter. And the residence time of the organics in the reactor, providing more time for the microorganism to degrade the organics. Number 3, percentage of COD reduction decreased as the initial concentration of wastewater increase. And next,
And next process that occur follow influent, effluent, and overflow. A method, the basic concept of the process consists of passing wastewater up through a packed bed of particles at a velocity sufficient to impart motion to or fluidize the particle. As the flow of the wastewater passes up through the biological bed, very dense concentration of organism growing on the surface of the bed particle consume the biodegradable waste contaminant in the liquid. Next. This is the process of entering and leaving the flue. In order to enhance oxygen transfer and to reduce the process footprint, full-scale fluidized bed generally altal column up to 10 meter in height. The performance implication of using such subtle column have not been fully explored. One effect of a large height to cross-section ratio is that effluent recycle ratio can be low and still have a high enough flow velocity for bed expansion. The lower recycle ratio and the greater column distance work together to reach larger surface gradient along the column lines. Figure 8.9 illustrates two types of circulating bed reactor, an airlift reactor and ejector mixed reactor. Airlift reactor are subdivided into upflow and downflow section. The upflow section reservoir aeration, which make it effective density lower and create the airlift pumping that drive liquid circulation. In an airlift biofilm reactor, like carrier particles are carried with the circulating water, creating a well-mixed biofilm distribution and a degree of complete mixing of the water content. It is equally possible to create a strictly liquid-driven circulation pattern by using an external recycle to create an ejector pump inside the reactor. Next.
Then advantage and the disadvantage. Next, please. First, the advantage. As the media on which microorganisms grow is in fluidized state, the surface of the media available for the development of microorganisms is quite large, which leads to the high concentration of microorganisms, and thus high flow rate can be achieved in FBBR. Like as I explained before, because of large concentration of microorganisms, FBBR bears high potential for the removal of various parameters such as BOD, COD, nitrogen, etc. FBBR is capable of accepting shock loads. Size of the FBBR plant is small as compared to other types of the reactor, and hence the space requirement is less. Next. The treatment by FBBR is economical where land cost is high, like as I explained before. If FBBR is operated properly, there is no need to provide secondary setting time, which leads to saving in the total cost of plant. FBBR provides an extraordinarily long sludge retention time for microorganisms necessary to degrade the symbiotic and toxic compound. The system operation is simple and reliable. Next. And now the disadvantage. The major problem is that it is not easy to predict back mixing and fluidization patterns, so we can really sure how well the mixing it is. Then main disadvantage of the FBR is the pumping power required to operate and the proper design of the inlet and outlet arrangement for proper distribution of flow. Like in the study case before, we know that the different design of inlet and outlet have different results. Next.
Okay, and the operation and maintenance. Next. Operation and maintenance. In the journal, Low Energy Single Stage Anaerobic Fluidized Bed Ceramic Membrane Bioreactor or EFCMBR for wastewater treatment is operated under a different operational mode with occasional maintenance cleaning. With no maintenance cleaning after 200 days, starting with a maintenance chemical cleanse and periodic relaxation is used. Maintenance cleansing is then carried out twice a week. For this, the peristaltic pump is provided for 3 minutes a backwash plug with 25 mg per liter sodium hypochlorite solution. Then a holding time of 30 minutes is given so that the chemical solution react with the pholan associated with the ceramic membrane. Finally, the permeate pump extract the cleaning solution from the membrane. This procedure prevents the hypochlorite from mixing with the reactor microorganism. The net flux is calculated by subtracting its maintenance, cleaning, and periodic relaxation time from the total operating time. For its clean flux, the sequence of operation includes step forward filtration, 17 minutes, membrane relaxation 1 minute, reverse wash 1 minute, and relaxation 1 minute. Okay, next. Okay, so that was a presentation from our group. We are sorry if there are errors. Thank you.